Hey everyone, I know I just posted yesterday, so I'll keep this one short. But today was my second day of classes at Wake Forest University in the Masters in Math. I actually am posting because I switched classes from one of the classes that I discussed yesterday because it's more relevant to the problems that I'm working on. But my classes that I had today in order were complex analysis at 8 a.m. In that class, we'll be covering everything that a normal complex analysis class covers at the graduate level. So we're going up to the residue theorem and some conformal mappings. As a grad student, I have to do a project. I'm probably going to do mine on the invariance of the Laplacian, maybe things like that, harmonic extensions. Those go a little deeper than just knowing that they exist. So there's some cool stuff there. I might also just do projective mappings, things like that are really cool. Maybe deformations of paths, things like that. There's lots of contours that are named in complex analysis, I think usually pertaining to number theory, things like that. My second class, I actually sat in on a geometry class, which is just called geometry, but the text they're using and the material they're covering is called geometry and cosmic topology, which is pretty cool. So it's an application of non-Euclidean geometry to the study of the shape of the known universe, or the shape of the universe as a whole. The visible universe to us is about 13 billion or a little more than that years, and the known universe, or the estimated size of the universe, is much larger than that. And that's not including the fact that we can't see all of what is technically the visible universe. So there's some question as to whether we live inside of some curved space, hyperbolic space, spherical space. So this class covers curvature and it's a transformation-based geometry class. So it starts off with the distinction between Euclidean and non-Euclidean. Like today we covered like Euclid's postulates and then disproved, or we proved that there are spaces that satisfy the first four that don't satisfy the fifth, which was an open question in math for a few hundred years, actually, or a few thousand. Yeah, a few thousand. Because Euclid formalized what was being done by the Pythagoreans, which was earlier. It was in the, I want to say it was in the 500 BC range. Yeah, after Thales, before Plato, right around there. So that's going to be a cool class. It's an just an axiomatic geometry class. And then I had topology with Dr. Sarah Rayner. Topology, we cover, point set topology and algebraic topology in 2 separate semesters. I think that's pretty normal. And the point set class that we had today was literally just like rehashing a lot of like set theoretic definitions of things that people haven't seen before. When I was in my undergrad, I took a formal class from a philosophy department in formal logic and set theory. So I'm a good bit ahead, but that's not the case for most people. So there's things like ordered pairs that haven't been presented in a mathematically rigorous way to people. We covered those, or I guess a set theoretically rigorous way, because mathematically you can just assume that they act the way they do and you're fine. And so that was my topology class. And I think we're working up to chapter 3 of Monk Race. We're going through chapter 3 and then into some stuff about like knots and manifolds and stuff. So that's pretty cool. Dr. Rayner is also my thesis advisor. She's really, really smart. She's like really smart. And I respect her a lot, so I'm excited to be in her class. And that one has, I think, couple physics PhD students, one undergrad, and 6 grad students. And I mean, God, that undergrad is impressive to even be in that class. Yeah, so I guess that's all I'm signing off with, is just that I switched from math modeling to geometry. What you'll find in the grad school is that it's a lot easier to switch those things around and work with people's schedules and stuff because you're only in 3, maybe 4 classes. And the geometry class that I'm in, I'm auditing, so I can just kind of drop it if my workload gets too high, which is nice. And that's all. Have a good one.